So we already decided on this number one that the x-axis needs to be the axis of revolution. And if any of you have ever like worked with building things or even like put together a chair, then have you ever seen a washer? Yeah, that's what these form. So whenever you have a situation like the bagel situation, each little slice is a washer. So what we're going to learn is called the washer method. And so what you guys did, I think I talked to everybody to get the volume of each slice. It was pi, and then the outer radius squared times the thickness, which is the change in x. And then you subtracted the inside cylinder, which was pi, and then the lowercase r, the inside radius squared times delta x. Okay. And so what we're going to do is number 5. We're going to do that together. So it says to use a green colored pencil to outline the part of the region in question 1 that determines the outer radius. So I'm going to go to question 1. And yours might look similar to mine. It might look different. But this top semicircle is what determined the outside radius. So we're going to highlight that in green. Not highlight, but color in green, I guess. And then the bottom semicircle is going to be blue. It determined the inside radius. All right. I know you're going to be flipping back and forth between pencils, but it also tells you on question 5 to label the top semicircle capital R of X, and then the bottom semicircle that was the inside radius lowercase r of X. So when we have a situation where you end up with a washer instead of a disc, we have to do 2 radii. And so I'm still going to do like what we did with the discs and go from the axis of revolution to my boundaries. So using the green pencil, we're going to go from the axis revolution to the boundary that's the farthest away. So that was going to be your biggest radius, and it's going to be capital R. And then from the axis of revolution to the closest boundary is going to end up being your inside radius, and that's going to be lowercase r. Okay. Now, the way I drew my bagel on number 1, it looks like I'm going to go from like negative 2.25 to 2. So that's what I'm going to use to do my integral on the last one. You guys can look and see what your x's look like. This really is not a big deal. So on number 6, we're going to write an integral that would give us the exact volume of the bagel. Now, when we did these, they both had a pi. Do you guys think it's okay if I pull that pi in the front like I did with the discs? Yes, let's do that. So it's going to be pi, and then it's going to be the integral. Now, my integral looked like it went from negative 2.25 to 2. You might change yours. It doesn't matter. And then it's going to be capital R of X squared minus lowercase r of X squared. And then what have we always been doing in place of delta X? Dx. Right? That's the washer method. It's very much like the disc method, but you have to subtract your 2 radii squared from each other. Right? So I think I put some notes, papers on your tables. We're going to fill these in. And like I was saying, we're doing a lot of these in the calculator. Don't be surprised that if on the AP test, you have to do these by hand. I just right now, I don't want you to stress about doing the integral. I want you just to be really comfortable setting it up. And then I know you can do an integral. I just don't want to add tedious, time consuming things to something that's kind of hard to understand. All right, so we're going to use the washer method. So now that we know two methods, you have to decide when to use which one. So we're going to use the washer method when there is a space or a gap between the region and the axis of revolution. Or the AOR. All right, and that's what happened on the bagel. All right, so I'm going to just draw a little graph over here. All right, and then this is going to be my region. I'm going to revolve. And I'm actually going to revolve it about this line down here. All right, I'm going to keep color coding with green and blue. And you guys are welcome to do that. It's up to you. But what we're going to do, we can see that there's space between our boundary and our axis of revolution. So that's a cue that we're going to have to do two radii. So we're going to draw sample radii from the axis of revolution to the boundaries of the region. So the one that is farthest away is going to be green. So I'm going to go from the axis of revolution to the farthest boundary, and that's going to be capital R. And I'm going to go from the axis of revolution to the closest boundary, and that's going to be lowercase r. All right. And then I'm going to write an expression for capital R and lowercase r. And that expression is just like what we did with our radius yesterday and the day before. So when you're writing those, if it's similar to this one where your radii are vertical, then you're going to think top minus bottom. And then you're going to make sure your boundaries are in terms of x. All right. And we're still going to have the case when your r's are horizontal. And when they're horizontal, you're going to think right minus left. And then you're going to make sure that your boundaries are in terms of y. All right. Then the last part is to set up the integral. And then today we are just going to let our calculators find that integral. But know that it's possible you may need to do the algebra and stuff and the calculus to find it on the AP test. So set up the integral. Okay, I should have made this box a little bit longer. I'm going to see if I can squeeze it over here. So our integral is going to be pi times the integral from a to b of capital R of x squared minus lowercase r of x squared dx. Or, see if you guys can fit one more. It's the same thing, but our variables are going to be y. Now we're starting off with one of the more difficult ones because, well, you'll see in just a second. So for number one, we're going to let the region let M be the region bounded by x squared, the y-axis, and the line y equals 9. And then we're going to find the volume of the solid created of the revolution, created when revolving M around the line y equals -1. All right, here we go. Let's draw this guy. Now on a calculator question, you obviously can use the calculator to get the graph, but we know what this looks like. It's a parabola at the origin. Right? And then it's bounded by that curve, the y-axis. I'm just going to make it a little bit wider. And the line y equals 9. So I'm going to shade my region. Okay. And then we're going to revolve it about the line y equals -1. That's going to be our axis of revolution. Okay. So we're ready to go through the process. So because there is a gap between the axis of revolution and the actual region, then we have to do the washer method. So I'm going to start with green, and I'm going to go from the axis of revolution to the farthest boundary. And that's going to be capital R. Bless you. And then I'm going to go from the axis of revolution to the closest boundary, and that's going to be lowercase r. All right. And then we're going to write an expression for capital R and lowercase r. And because this one, our radii are vertical, we're going to think top minus bottom. So for capital R, what's the top? 9. What's the bottom? It goes all the way to the axis of revolution, -1. So that's just going to be 10. So everywhere on this revolved solid, the outside radius is 10 everywhere. Okay, for lowercase r, what's the top? X squared. And what's the bottom? -1. So that's the same as x squared plus 1. Okay, so we're almost ready to do everything on our integral. But I'm going to start it. We're going to have to stop. So it's going to be volume, or V equals pi. All right. So we have some sample radii that we're going to fill in all through our region. So what x are we going to start with? 0. Do we know what x we're going to stop at? Yes. So it doesn't, we don't have that written yet, but I know that y is 9, and I know that I square 3 to get 9. So we're going to go from 0 to 3. And then this is going to be 10 squared minus x squared plus 1 squared dx. All right. So I want everybody, as soon as that sinks in, type it in the calculator. Let's make sure we can all get the same thing. Do you guys get 723.823? And I recommend just type it in all at once. I mean, you could, if you want to do 10 squared in your head and do 100, that's fine. But if you just type it all in, it will all work out. Okay, I have a couple more to do and not a lot of time. So for 2, G is the region bounded by y equals 2x plus 2 and y equals x squared plus 2. We're going to find the volume of the solid generated when G is rotated around the y-axis. All right, so this one is going to be more difficult in some ways and slightly easier in other ways. Okay, so we know what this looks like. This is a line with a slope of 2 and a y-intercept of 2. So just kind of estimate that. And it is a parabola that has been shifted up 2. So the vertex should be at this point right here. So you guys draw that parabola, making sure it crosses that line 2 times. All right, and then this is my region. Now that vertex, I didn't draw it great, but that vertex should be at that point of intersection. All right, so that's our boundary. That's our region. Sorry, that's our region. And this time, our axis of revolution is the y-axis. So we're going to revolve it around the y-axis. And I can see there's a gap. There's a gap between our axis of revolution and our boundary. So I'm going to have to do the washer method, which means I need a green radius that goes from the axis of revolution to the farthest boundary, and that's going to be R. And then I need a radius that goes from the axis of revolution to the closest boundary. That's really small. Closest boundary, and that's going to be lowercase r. So, because these are horizontal radii, what am I going to have to do over here? Solve them for x. We need it to be y whatever, or there's y plus something. So they're not too terrible to solve. So I'm just going to subtract 2 and divide by 2 to get that one. This one I'm going to subtract 2 and do the square root to get that one. All right, so anytime when I'm writing these expressions for the radii that I want to use the line, I'm going to do this one. And anytime I want to do the parabola, I'm going to use this one. All right, so R, capital R, I should say. And we're thinking right minus left. So what's on the right side of that radius? Right. And what's on the left? The left would just be 0. So the y-axis is 0, the x-axis is 0. So we can put minus 0 if we want to, or we can just leave it. You guys do what you want to do. All right. And then lowercase r, the right is going to be the line, which is y minus 2 over 2. The left is also going to be 0. Okay, so we're almost ready for our whole integral. I know it's going to start off with v equals pi times an integral. And I also know I'm filling in all the radii for that region, from the bottom of the region to the top of the region. So what is the y at the bottom? 2. Now to get the y at the top, it takes some algebra or using your calculator. We don't have time. But that is going to be the 0.26. So last class I solved it for x and then plugged it back in to find it. So I just set these two equal, solved them for x, and then plugged it back in to get my 6. So. All right, then we're ready to set it up. So it's going to be capital R squared minus lowercase r squared dy. All right. So when you guys plug that in, you should get 8.378. All right. So this last one is going to be quicker because it's already drawn. We already know our boundaries. We already know our limits, so that's good. This one is going to be rotated about the x-axis. And there's space, so I know I have to do a washer, so I'm going to have to do a capital R and a lowercase r. Capital R goes from the axis revolution to the farthest boundary. Lowercase r goes to the closer boundary. So which one of those functions is the one that's farthest away, the cubic or the sine? The sine. So it's going to be sine of pi x minus 0 or just sine of pi x. And then r is 8x cubed minus 0 or just 8x cubed. All right, you guys set this up while I'm handing out the papers. All right. So we know it's v equals pi. What are my upper and lower limits? 0 to 1/2. And then it's going to be sine of pi x squared minus 8x cubed squared dx. And if you type that in, it's pretty small. It's 0.561. All right, your assignment looks like it's a lot. It's 4 problems. I wanted you guys to see this template to kind of help you decide if it's a disc or a washer. It kind of takes you through step by step. You can choose to use the template or not, but half of these are discs, I'm pretty sure, and half are washers. So you do have to make that decision now, which method to use.